Alright, hey guys, welcome to another episode of Learn with Anirudh. This is the fourth part in our five-part series of the sorting algorithms that we are discussing in Python. And of course, in this episode, we are going to take a look at merge sort. So, ladies and gentlemen, what are we waiting for? Let's get started. So guys, I hope you have had a chance to take a look at all the previous sorting algorithms we have taken a look at in this series so far. We've had a chance to take a look at bubble sort, insertion sort and selection sort. All those episodes are already up on the channel, so make sure you guys are taking a look at that. The links are available in the description box for that as well. And similarly, in this particular episode, we are going to take a look at merge sort in detail. We're going to be taking a look at real world examples that you can relate to. I'm going to be breaking down the entire algorithm into the most simplest terms. And of course, it's not just theory here at Learn with Anirudh. So we're also going to take a look at Python code. And as I told you in the previous episode, merge sort and quick sort can get slightly complicated, especially if you're a beginner. So make sure that you guys are paying full attention. And if you are, trust me, by the end of this episode, I am 100% confident that you guys can sort any array that you want by using merge sort, and it's going to be as simplified as it's going to get. So let's get started with merge sort really quickly. Well, merge sort is a very different algorithm to the one that we checked out last time. The last algorithm we checked out was selection sort. Selection sort did something called as an in-place sorting. It used a technique called as in-place sorting. And here merge sort works in a very different way. It's a radically different approach. It's called as the divide and conquer approach. Now, what do we mean by divide and conquer? As always, let's take up an example to bring you an ample amount of clarity really quickly. Let's assume that you're a teacher right now and you are just grading your students' examination papers. There was a quick examination that happened. All the students gave in their answer papers and they left. Now, if you were an external faculty and you don't know the students, you will of course want to arrange it in the ascending order of their names, ascending order of their roll numbers, or something like that. So you're taking the papers home to evaluate it, and an important thing, mess up happens where all the papers get jumbled on your car seat. So they're no longer in order right now and they're all messed up. For us to sort an array, this is beautiful, but probably if this happens in real life, it might be a huge pain. So what would you do? You would start ordering it based on alphabets. Now you'll have various students. Let's just say there were 100 students. There will be a lot of students whose names start from A, whose names start from B, C, D, and so on. So there's a good chance you're going to just keep all the people or in all the papers whose name starts from A on one side, B on the other, C, D. So you're going to keep ordering these into separate sections, and you're going to divide the 100 papers into tinier sections, and then you're going to work through those tinier sections to eventually have one big sorted set of your papers. That would be the most meaningful approach that you would have taken, because I remember, if you remember a movie, very popular Bollywood movie called Three Idiots. There's a scene where they jumble the papers and run away. So my entire train of thought here was exactly that. If you were to go on to reorder that paper, that lecturer would have definitely wanted to use this approach. Now, anyway, let's take a look at the example. Let's consider that, one is A, two is B, however you want. I just didn't want to take up alphabets to confuse you anymore, since in your practical, in your real life, in your interviews, there's a very good chance you're going to be given an array and asked to use merge sort. So let's dive right in. Here is a very simple array which has about 7 elements. As you can see, it is not in the order. One thing you can do right now is take your pen and paper, pause the episode for a second, and sort this out manually. Sorting this out manually will hardly take you 10 seconds, and I bet all of you all can do it. Now let's see how we would go about doing it if we were to use merge sort. Merge sort is very simple, and since we're going to be doing it in Python, or you can also implement it in any programming language you want, Python looks at an array as various positions or various index elements. Now, what if there was only one element that you could pass into the array and ask it to be sorted? Our common sense will tell us that if there was only one element, your entire array, let's say it's only one element, it would have already been sorted. There is nothing to compare it, correct? So you have to make sure your algorithm doesn't fail for that case. So this is the reason we have our step one here, where we check if there is many indices out here. So as you can see, in our case, of course, we have 7 elements. So there's going to be 7 index positions, and we're going to check if there are 7 index positions from the left to the right. Now, the 5 that I've highlighted is the value, but what is the position there? Since Python is a programming language that indexes from 0, This is the zeroth position, correct? Zeroth position. This is index 1, index 2, index 3, index 4, index 5, and index 6. Now, all we are trying to compare is here, we're getting Python to understand that there are more than one element there. So all we're telling Python is, hey, just check if your left index is lower than your right index. Don't look at the value, look at the index. And if you have that, it means Python understands at this moment that there are multiple elements in this array. And once you have multiple elements, since merge sort is a divide and conquer algorithm, it's very simple. We just start cutting it at the center. We know the lower index, we know the higher index. It's very simple, just divide it by 2, you're going to get the middle position of it. And once you find the middle position of it, you're going to split the array into 2 parts right there, as you can see. Now the middle position was after 1. So what happens here is that I'm going to split the array in that position. Now you have 2 arrays. 5, 4, 6, 1 is one array. 2, 7, 3 is another array. Okay, so how are we dividing it further is a question that you might be asking right now. Well, take a look at your screen. We have 5, 4, 6, 1. Don't you think we can split it as 5, 4 and 6, 1? And we have 2, 7, 3. 2, 7, 3 can be split as 2, 7 into one part and 3 into another part. So the goal here with merge sort algorithm is that we're going to keep calling the algorithm on itself until it divides everything out to a point where you cannot divide it any further. So we have 5, 4 and 6, 1 split out, as you can see on your screen. And once you actually perform that split, it will look something like this. 5 and 4 become one unit, 6 and 1 become another subarray, 2 and 7 become one array, and 3 is a loner for now, so 3 is going to become separate, right? So we've divided it, but is this the final array which you cannot divide any further? I know you guys are saying no right now because you can still divide this into each individual element. 5 and 4 can be separated out, 6 and 1 can be separated out, 2 and 7 can be separated out, and since 3 has been separate, it's basically been third wheeling all this while, so it's going to be separate there, right? So fantastic. Now we have these 3 groups and we have the third wheel out there as well, and this is the maximum that you can divide. Now if you remove those yellow lines you can see on your screen, there is no further division that you can do. Each of these elements are at its simplest, at its most divisive state that they can be, correct? So right now we have something called divide and conquer. We have done with the dividing part. Now it's time for the conquering part. Conquering part is where we actually try to find each block, sort the things out, and eventually start merging. So let's take a look at how it goes. This was the divided part that we just took a look at, and eventually once you start bringing the elements together, it is very simple. It's just like any other sorting algorithm. Observe 5 and 4 right now. 5 and 4 are not sorted in the ascending order. So once you go about sorting it, what will happen? 5 and 4 is not in the order, so eventually we know the correct order is 4 and 5. So we'll have a simple if logic to go about swapping that. Okay, 4 and 5 are swapped. What about 6 and 1? Similarly, 6 and 1 are also out of place. You know that 1 has to be before 6 in that particular comparison, so you do another swap. Imagine with 2 and 7 now. 2 and 7, you don't have to swap anything because when you directly compare 2 and 7, 2 is smaller than 7. So for now, it is going to hold its position. And finally, our third wheel is just going to keep continuing to third wheel for a while. All right. Okay, so this was good. We have split it into multiple elements and now we are trying to sort it out at its block level. What next? The next part is very simple. We have to bring it together now. We have to bring all the sub-arrays together. To bring it together, we can still divide it into multiple parts. Now take a look at the highlighted blue color box out there. We're going to compare every element from 4, 5, 1 and 6. We're going to compare each element to the other and we're going to find which element is greater and eventually start sorting it then and there. So as the starting index 4 and the ending index to be 6, don't you think the smallest element in those 4 elements is 1? So what do you think is going to happen? Of course, once we start using these indexes and once we start understanding, we have to only look at those 4 elements. Again, apply a sorting logic there and eventually you can sort it out simply. 4, 5, 1 and 6 will become what? 1, 4, 5 and 6. Okay, one block is now completely sorted. Half of our entire array is sorted. Take a look at the next half of the array now. Similarly, we're going to make a comparison here. We're going to compare every single element out there with every other element and we'll go from 2 to 7, 7 to 3 and we're going to take a look at what happens when we have the final comparison and swapping done. Once we have the final swapping done, 273, of course, if you swap it and make it into its correct order for that sub array, it's going to become 2, 3, and 7. Fantastic. So take a look at your screen right now. In this moment of time, you have two sub arrays which are beautifully sorted, beautifully ordered. But can you just merge them together right now and think that they're sorted, or do you think it'll work? 1, 4, 5, 6 are sorted, but as soon as you start putting 2 next to 6, once you start bringing these two together, it's all going to mess up. So we are still not done with merge sort. So we keep calling the algorithm again and again, and we start making comparisons more. So how do we go about doing this? Pay attention here, because this is where beginners tend to mess up. This is where freshers get really confused about how merge sort actually works. So here what happens is we're going to start comparing each element on the left with each element on the right. Simple logic. Write it down somewhere in merge sort. Compare every element in the sub-sorted array with every other element in the other sorted array. Done deal. So compare 1 and 2. Which value is smaller between 1 and 2? 1, correct? So put it in its final position because 1 is smaller than 2. What next? Compare 4 and 2. Between 4 and 2, which is the smaller element? It is 2. So bring 2 out and put it next to 1. What next? You can guess what happens right now, right? So you're going to compare 4 and 3. When you compare 4 and 3, what's going to happen again? 3 is smaller than 4, so we're going to bring 3 outside. And once you compare 3 and 4, and once you understand why we are moving through the array like that, take a look at the next step. The next step is us comparing 4 all the way with 7. So what happens when you compare 4 and 7? When you compare 4 and 7, we understand that 4 is less than 7, 4 is smaller than 7. So eventually we bring it and order it out. So we are still not done. We only have 4 sorted elements in our final array. The next element that we want to go and compare is 5. So we're going to compare 5 and 7 here. And what is smaller between 5 and 7? The answer is 5. Now you might be wondering at this moment of time saying, hey Anirudh, why are you not comparing 5 in between 2 and 3? Why are you directly comparing 5 and 7? We did that in the case of 1 as well, and when we were in 4 as well, we just made a direct comparison with the elements ahead. We didn't compare it with smaller elements. Now that is because these elements, when you're comparing, you're directly sorting it as well. So you couldn't have a chance to compare these two elements, 4 and 2, let's just say, or 4 and 3, because you already had sorted it at the moment. So in that sense, the algorithm here is efficient enough. Unlike all the bubble sort, insertion sort, and selection sort algorithms, merge sort is very, very intelligent, and it knows for a fact that it does not have to waste time in making that comparison. So it won't bother doing it at all, because it knows if 1, 2, and 3 are already ordered, there is no need to compare anything with that, because there can never be another element in the entire array which is smaller than that. This is the reason why merge sort and even quick sort for that matter are super efficient at doing its job rather than that. Now there's terms on the lines of time complexity and space complexity, and if you directly take a look at the time complexity here, the time complexity of merge sort is basically n log n, whereas most other algorithms it is n square. Now it's okay if you do not understand what time complexity is. I'm gonna make another episode where we're gonna be discussing how you can analyze all of that in depth. Now anyway, coming back to that, we're still not done. 5 is smaller than 7, so we got it. The next thing is what? You do not compare 6 with 2 and 3, because we already done with 2 and 3. So you directly compare 6 with 7. As soon as you compare 6 with 7, 6 was a smaller one and you put it there. Now which element is left? After everything, you have only one element that is left, which is 7. Common sense tells us that if you've already picked out all the smaller elements compared to 7 and you already put it there and sorted, whatever element remains at the last has to be the largest element. So all you try to do is you directly lift it there, put it in its final place, and boom, you are sorted. So ladies and gentlemen, this is simply how merge sort works. Just compare each element with an element that is greater than that element in the next set of array, move through it in an order, and once you start doing it, especially if you have your pen and paper handy, if you just pick up a few numbers and do it manually, you guys can just figure it out. And if you do it 2 or 3 times, I bet you're not going to forget merge sort for any of your interviews. Now let us just try to take another simple example. This time we'll not take a look at it algorithmatically. We're going to take a look at it in a practical, simple approach of how you would do merge sort mentally in your head. Okay. So here I've added some colors so that you guys can just have a better idea of following along with each numbers. We have 5 elements in the array. 8, 5, 2, 9, 1 are the elements. So divide and conquer. So we just have to start dividing until we cannot divide any further. We're going to divide it out 8 and 5 becomes one unit, 291 becomes another unit. 8 and 5 can further be divided, 2 9 and 1 can be further divided into 2 9 and 1 separate, as you can see on your screen. Now don't worry, 8 5 didn't go anywhere, we're going to be splitting 8 5 as well. And at the end of the divide stage, take a look at the very last part, very last portion here. With this, the dividing part of it is done. There is nothing further that you can divide at this point of time. So once you're done with dividing, what do? You start conquering it, you start merging it again. And once you start merging it again, it's a very simple task. You just have to make comparisons. You compare 2 and 9, and 2 and 9 don't need any reordering, so you just bring it together. 1 is third wheeling in this case, just like how 3 was third wheeling in our previous case. So you're going to keep it as it is for now. So here you have to understand that 2 9 didn't require ordering, but as soon as you bring 1 into that particular chain, it's going to require some ordering. So 2 9 1 becomes what? It becomes 1 2 9. And 8 5, what we had, doesn't remain as 8 5. 8 5 becomes 5 8. So again, at this moment of time, you have two sorted sub arrays, but as soon as you start bringing it together, it's going to mess up. But as soon as you manually look at it in your head, this is the approach of this example. So as soon as you manually start working it out in your head, this is exactly what you would do, right? You're just gonna scan through all the elements, quickly make a comparison, start finding one small element after another or one large element after another, since we're doing it in the ascending order right now, and eventually start placing it. The colored arrows are going to be a guidance. So take a second to pause the episode here and take a look at all the colored arrows, colored lines, and the step-by-step approach of how we divided it, and whatever final array we had. Basically, our input was 85291 and our eventual output was 12589. And this is literally how you would go about doing it in your head. And in the previous example, I just showed you how you would go about doing it algorithmatically. So either way, if you have to quickly do it in your head or if you have to put it on paper and show how it works algorithmatically, you now know how to go about doing this. So let's quickly recap and understand how we sorted it out. The first step with merge sort is very simple, ladies and gentlemen. If there is only one element, consider it to be sorted. There is no sorting you can do if there is one element. This is with almost all the arrays, right? If there's only one element, you cannot compare it with anything else. Now, what was step number 2? Step number 2 was keep dividing the array into multiple parts. When you say multiple parts, find the lower index, find the higher index, cut it exactly at the middle, like how you were sharing chocolates with your siblings or something. There you would have cheated, here you cannot cheat. So it's very simple. So keep dividing it at the middle point until you cannot divide further and you have each single element. And once you have the element, just compare an element greater than that and eventually start bringing elements together and start repeating it. In the places where we had the sub arrays, what we are trying to do is we call the entire merge sort algorithm again on that array. So you divide it out, and while you're bringing it together, you call the algorithm multiple times on one part of the array, call the algorithm on the other part of the array, and you keep doing it until the left array is sorted, keep doing it until the right array is sorted, and as soon as you bring it, it's all going to go to crap. So eventually you're going to have to do it again. And once you do it, once you call the merge sort algorithm, finally it'll all be merged and you will have one single sorted array. So that is how we can go about doing this theoretically and understanding how we do it in our head, understanding how it goes on working in the algorithm. But I think it's high time we take a look at this practically. And I know you guys have been waiting for the Python code. So what are we waiting for? Let's quickly open up Google Colab and let's take a look at how we can implement this practically. Alright guys, as you can see from your screen right now, we have Google Colab up and running. We have the code for merge sort algorithm here. I've zoomed in enough and I hope all of you all can see the code. Now this might look a little bit lengthy when you compare it to be it selection sort or be it bubble sort, but the logic here is very simple. Let me explain line by line about what happens. The first line is very simple. You guys should already know what's going on here. This is the actual input array that we're going to give. Unless we have an input, we cannot have an output. Simple as that. And then we have a function called as the merge function. Now this function is going to be of huge help to us because no matter which array, which sub array or whatever it is that you're calling, you're going to use this function to actually do the sorting. Okay, so look at this. The next line says if the length of your input array is greater than 1. Now we're making an assumption to say, hey, if it is only one element, already sorted. If it is more than one element, let us sort this. So if it is more than one element, even if it was just two elements, you can cut it at the middle and make it into two sub arrays, correct? So that is exactly what we are doing here. We're going to find the lower index, we're going to find the higher index, and we are going to perform a floor division. A floor division, basically, I'm going to give you an example if you don't know what floor division is. Now divide 5 by 2. What is the value of 5 divided by 2? It is 2.5. But as soon as you do floor division, as soon as you start dividing 5 by 2, here it will remove the floating point part and it will have only 2. So even though your calculator says it's 2.5, if you do floor division, it's going to floor the value down to its integer value and we're only going to have 2. Got it? So after you found the middle position here, 2 is basically the index position of 0, 1 and 2. So we're going to be cutting the array exactly where you see after 2. So look at this. This is where we're going to be splitting the array into two parts. Everything from the start until the middle element is going to go into the left array. Everything from the middle element until the end, right? Make sure you're observing the colon here. The colon is very important. So this is going to basically dictate what's going to happen. Everything from start until mid, everything from mid until the end, correct? And look at this. This is where all the magic happens. We're gonna call the same algorithm. We're basically going to call the same function on both of these subarrays. We're going to sort the left array, we're going to sort the right array, and then we're basically going to use the same logic until every element in the left array is sorted, every element in the right array is sorted. Once we bring it together, you saw how it can mess up, so we have to do a bit of comparison and fix it up. Now to break it down into the left array, break it down into the right array and perform comparisons, you have to also understand that we are swapping the elements here. Once you start swapping the elements, you can use two approaches. The one simple approach that you can use is create temporary arrays to copy all the data into. Now take a look at this. We have a simple while loop here that says while I is less than length of left and j is less than length of the right, if the element on your left in that particular index position is less than element on the right, just swap those two elements and keep it ready. When we broke it down into simple elements and when we started merging it together, we did those two simple comparisons, right? This is exactly the logic there of what happens on the left side or what happens on the right side. We're basically shifting the array into its two parts, and in those two parts we have already started playing down. Okay, so what this is going to do is this is going to compare those sub arrays and eventually make the swapping, but you will not have a guarantee. The algorithm has still no way of understanding if it has sorted through the entire array. Is your final array sorted? That is where we have this logic. This logic will basically help us to understand if every single element was compared with every element that has been greater than that. You remember that part where I told you don't have to make meaningless comparisons? This is the logic which tells Python you don't have to make meaningless comparisons and you just have to make the comparisons that is required. When we were swapping something like 6 and 7, we don't have to compare 6 with 2, 3 or 4 anymore. That is what makes other algorithms inefficient, but we don't do that here, and merge sort is no wonder a top sorting algorithm. And after this, basically this entire thing is all we're trying to say here is just split the array into two parts, sort each of those two parts, and in those two parts, make sure that you have gone through all the elements, make sure you have sorted all the elements, and as soon as you're done with that, just have a simple print function that's going to print all the elements of your final array. So this is a very simple message out here. All we're trying to do is we're trying to print the input array, and eventually we're going to call the function here. It's the merge function. Basically, as soon as I start calling this, the entire logic is going to go here and it's going to finish working and doing its thing. And all we are doing is printing the output here. Now, okay, ladies and gentlemen, at this moment of time, I want to say that since this is a very large code, I don't want you guys to start typing this out manually and scrolling and pausing the episode. Just go to the description box right now. This entire Jupyter notebook, the link to this exact Jupyter notebook is available. Just open the link, sign into your Gmail account, and you're going to be brought to the exact page, the exact program, and you guys can save it, start working with it, and eventually learn it in a quicker fashion, right? Now let me execute this. As soon as I hit the play button, our input array was what? 85291. We already know what the answer to that is. As you can see, our input was 85291, and as soon as we used merge sort, it became 12589. Okay, let us change things around. Let us give this a couple more elements, 100, 150, and 3. I think this should be good enough, right? So let me hit play and let me scroll down. Now I didn't want to like look at this once, look at the output once. That's the reason I already have the input also printed here. And as you can see, we added these 3 new elements. We used merge sort again and it is sorted, right? 1, 2, 3, 5, 8, 9, 100 and 150 are sorted. using merge sort. So this exact Jupyter notebook is available. Just head to the description box below, follow the link. It will bring you directly to this particular page, and eventually all of you all can have access to the exact same program for your learning. Make sure you guys are adding more arrays here to get this to work. And with that, we're going to come to the section where I want you guys to actually start working on the quiz questions. As always, with Learn with Anirudh, there are going to be 1 or 2 quiz questions that I want you guys to work on. You have your choice to actually directly copy all of this into the input array, just put the output out there and hit me up. But the better way that you can take is, now that you know the logic, you know how the algorithm works, you know how merge sort works in Python, you know how merge sort works in your head, how it works on paper. Take a second to figure the logic out, take a second to look through, feel free to watch the entire episode again from where we discuss the theory or the example or the code, and try to see if you can sort this out. If you are struggling with the programming part of it, do not worry. Sitting in an interview, you're either going to be asked to write the pseudo code or you're going to be asked to do it manually step by step. It is very, very rarely, unless you have a programming round, that someone is going to ask you to implement this, and you also know how to do it now. So start doing this manually and let me know in the comment section. Hit the comment sections below, since this is a very important concept for all of your interviews. I want to see you guys be ready for all of that, and I hope the theory part, the question answers part, the algorithm part, the coding part, we've had a chance to take a look at all of that, and I hope you guys are now ready to tackle all of your interviews, because I believe in you guys and I know you guys can definitely go about acing that. So ladies and gentlemen, it becomes very important for you to understand that it's not just merge sort that might be asked in your interviews. There are many other algorithms: bubble sort, insertion sort, selection sort, and with this episode, we are done with merge sort. So do take a second to hit the subscribe button if you haven't, because we're going to be discussing merge sort in the very next episode to wrap up our sorting algorithms in Python series. This series consisted of 5 videos. This is the end of the 4th one. We're going to be beginning the 5th one in the very next episode. So I want you guys to be a master of all of these. I want you guys to be completely thorough in all of these. And by the end of the 5th episode, if you guys have followed through every single minute of all of these episodes, I am 100% confident that all of you all know how to use these sorting algorithms completely on paper and with Python. So what are you guys waiting for? Hit that subscribe button if you haven't. Have a nice day ahead. Practice all of these, and I'm going to see you on the next one with the quick sort episode very soon. So stay tuned. Cheers.